Hello, I'm Eric Scripseth, and my project is an exploration of some causes for water quality variation in central Cambria County, PA. This map shows the initial question about mining's effect on water quality that I was intrigued by when looking at this area of Pennsylvania. The underground mining areas are shown in brown on this map. The streams that are not contaminated are blue, and the streams that are contaminated are red. I noticed for central Cambria County that although most of the contaminated streams were due to mine drainage, there were streams in mining areas that were not contaminated. I decided to explore the reasons why. I didn't find a convenient political boundary to use for my project, so I just made a rectangle to bound the area of interest. It includes the middle part of Cambria County and small areas of the counties to the east and west. The water quality information and the mining information are both from the PA DEP. In this presentation, the base map is always the USGS national map. I first became aware that Pennsylvania had an an abandoned mine drainage problem when I visited this stream drainage when exploring my new home. The reservoirs in this map are part of the City of Altoona water system, and some of the side streams that are sometimes very orange are routed around the reservoirs in concrete channels. Burgoon Run flows out of the eastern part of my project area and into the urban area around Altoona. This has been a wet year in this area, and this has diluted the mine drainage in this stream. So the color of the water is more normal looking than it sometimes is. According to the Eastern Pennsylvania Coalition for Abandoned Mine Reclamation, abandoned mine drainage, or AMD, pollutes more than 2,800 miles of streams in Pennsylvania. Some of the drainage in this stream, Burgoon Run, flows from my project area into Blair County, Pennsylvania. I am in Leopold Park, just west of Altoona, Pennsylvania. The orange color of the stream bed is a frequent characteristic of AMD. The next slide will talk about the chemistry of abandoned mine drainage. The chemical equations on this slide, where sulfides of iron are combined with oxygen and water to produce dissolved iron and sulfuric acid, show the beginning and ending of a series of reactions that lead to the results on the right. At the end, the iron and acid are in solution in water. The acid then dissolves minerals out of the surrounding rock, usually more iron, aluminum, and manganese, but can include other minerals depending on the local geology. If this soup of acid and minerals escapes the source area, it becomes abandoned mine drainage. One thing about the equation that is important is the requirement for free oxygen for it to occur. Controlling the oxygen is one way to control the AMD. I obtained geologic data about the coal deposits in Pennsylvania from the U.S. Geological Survey. These were polygons delineating the boundaries of the coal deposits with different sorts of information in the attribute table. One table that I found particularly useful indicated the depth of overburden over the coal deposit. The lower Cattonig layer is the deepest coal deposit that has been commercially exploited, and it sits below the upper Freeport layer, and those layers are below the Pittsburgh layer, which is almost absent in Cambria County. This slide depicts the upper Freeport coal beds sitting on top of the Cattonig layer, and a few isolated brown spots depicting the remnants of the Pittsburgh layer. Overburden is the amount of rock over the coal seam. It can be as high as 1,200 feet thick for the upper Freeport layer in places in Cambria County, and the lower Cattonig layer sits under it. In several valleys, erosion has removed the upper Freeport layer and given access to it from the side, and made the depth to the Cattonig layer much less. Natty Glow sits in one such valley and has had a lot of mines because of it. I decided to compare elevation to water contamination because I began to suspect that mining activity might be concentrated in the valleys because of easier access to the coal seams. I obtained a digital elevation model from the National Map Viewer and clipped it to my area. This map shows the lower elevations as shades of yellow, and there does seem to be a correspondence from the contaminated streams and the valley. I decided to add more mining information from the PADEP. This slide is a portion of my project area, and it indicates that the mine entrances, waste piles, and various processing areas are often, but not exclusively, in the valleys. There were some large mines, particularly near Evansburg, where the decision was made to hoist the coal out of the mine. I did determine that many of the water discharges from the underground mines were in the valleys. Remember when I mentioned that oxygen was important for the reactions that produced abandoned mine drainage? In researching point source AMD flows from underground mines, I discovered that the deepest mines, where the workings are below the entrance level, often fill with water when the mine is shut. If this water doesn't have a quick outlet, the reactions that produce AMD deplete the oxygen in the water and the reactions slow down or stop. The mines where the outlet is below the mined area are more likely to have water and available oxygen regularly replaced as the water drains away, and these are available for the reactions that produce AMD. Counterintuitively, the drier mines produce more AMD than the ones that are filled with water. This slide shows polygon shapes of the surface effects of mined areas. Surface sources of AMD include surface mines, also known as strip mines, and coal mine waste piles. I had previously mentioned coal mine waste piles. In eastern PA, these piles are known as kerm piles. In western PA, they are known as gob piles. When I think of the word pile, I tend to think of something that I can deal with using a wheelbarrow and a shovel. That is not what these are. The biggest of these piles in my project area originally contained 40 million tons of coal mine waste. When coal was extracted, a lot of the rock, sand, and clay came with it. The process of separating and sorting the coal from this material was not very efficient, especially early in the mining period when it was done by hand, and a lot of coal went into these piles. These piles did not contain enough coal to burn efficiently with the technology of the day, but did contain enough coal waste that they could catch fire. The piles don't support plant life, and rain and groundwater penetration produces AMD from the piles. Some of the chemical reactions that occur within the waste rock are exothermic and generate enough heat to set the piles on fire. This plus lightning strikes and human-caused fires means that these piles are often burning. Revlock, PA is a few miles west of Evansburg, PA, and it had one of these piles immediately next to some of the houses in town. This pile was frequently on fire, and when remining of these piles began in 1991, this was one of the first piles to be removed. The multispectral imagery in the map shows Landsat 5 imagery from 1990 and Landsat 8 imagery from 2017. The Landsat imagery is from the USGS Earth Explorer website. I also did an NDVI for 1990 and 2017 for my project area to show vegetation health, and the maps on this slide show multispectral imagery of the area near Evansburg, as well as the NDVI and change map for the associated area. I deliberately put the scale directly below the gob pile in the multispectral imagery. This is the pile that was originally 40 million tons, and you can see how reclamation is progressing in the NDVI images. When you see the piles in the next two videos, keep in mind that the pile shown on this slide was originally 4 times larger than they are. We're here in Ernest, Pennsylvania. This is outside of my project area. I'm here with Sean Simmers, who is an environmental engineer with my current employer, That's Sean off in the distance. He used to be the environmental engineer for the company that is remining this coal pile. This pile originally contained 11 million tons of waste coal that is being reused to generate electric power. They're down to the last 300,000 tons of remaining material. If you look off in the distance from this vantage point, the tall trees in the distance is the original end of the pile of coal. It is the coal was originally about 80 feet thick at this location. We are near Homer City, Pennsylvania. This is a coal waste pile from the Lucerne mine that they just began remining in 2012. It originally had 9 million tons of material. They've removed about half of it. If you look over on the other side of the highway, you can see this clay-covered pile that they are reclaiming. That was a mine pile that was already recovered. We are 10 miles from the previous pile that was displayed, and the coal mine that produced these piles actually ran between these 2 points. This slide displays 2 gob piles that are being remined and reclaimed. In 2018, the remining of the right pile is nearly done, and the reclamation of the left pile is well underway. Remining has some controversy since those who are opposed to consumption of fossil fuels tend to see that and not the benefits. I have read articles from national environmental groups who are in opposition to remining these piles that do not mention the benefits of cleaning up the sites where these piles sit, do not mention eliminating the AMD from these sites, and they also don't mention that these piles often catch on fire and release the same material into the atmosphere without any corresponding benefit. The groups involved in abandoned mine reclamation tend to see the same process as a tool to help them eliminate one of their larger sources of AMD. This is a Google Earth image of the gob piles on the south side of Nantiglow. The process of remining and reclaiming these piles includes removing the coal waste, sorting out the completely unburnable material, then trucking the material that can be burned to a power plant where it is mixed with limestone to control the sulfur in the coal waste when it is burned. The ash from the combustion process is alkaline. It is trucked back to the gob pile and mixed with the acidic soil under the pile and the remaining rocky waste and then reburied. It is capped in clay and then soil and then planted with vegetation. We're looking north from the easternmost of the 2 coal piles at Nantiglow, Pennsylvania. This pile is almost completely reclaimed. Most of the coal is gone. The reddish and yellow colored rocks are called red dog. Those are areas that had fires in the coal piles while they were sitting here on the ground. There's a small amount of material yet to be removed that is usable, and then the rest of the pile will be covered and planted in grass and brushy vegetation. One water pollution source that I just barely looked at was surface mining. I decided to see if a slope map could help identify strip mines. I suspect, but have not verified, that the very thin but steep area on the left side of this map is the high wall left from a poorly reclaimed strip mine. These are some of the many topics left to explore when investigating this topic further. Sometimes presentations about environmental problems focus on the negative. I want to end this program by mentioning that a lot of progress has been made, but much remains to be done. AMD isn't really one problem. It is thousands of individual problems, and they need to be solved individually. Passive and active treatment systems have been installed in many places to control discharges from mines. Gob piles have been remined and the sites reclaimed. Abandoned strip mines have been reclaimed. Nature is sometimes slow to act, but it can heal the wounds from mining as well. There are now fish in the south branch of Blacklick Creek that flows through Nantiglow. We will end this presentation by visiting the site of the gob pile that was removed at Revlock. This is the site of the coal pile that was located just outside of the town of Revlock, Pennsylvania. This pile was on fire repeatedly before reclamation started. Reclamation is complete at this location, and you can see by the wetlands and the forest on the hillside that is now coming into view that was planted 20 years ago how successful that reclamation was.